Today we're going to be talking about whether or not an ordered pair is a solution to a linear equation. So first we have to talk about what a linear equation looks like. We have here ax plus by equals c. This is what we call a standard form of a linear equation, where a, b, and c are real numbers, so any kind of number, 0.6, 2, -5, a half, any real number could be a, b, or c. And x and y are the variables. Now, a linear equation, a or b could be 0, meaning if a was 0, 0 times anything would be 0, so this x would be gone. And I'd just be left with y equals c, or some constant. Or b could be 0, in which case y would be gone, and x would equal some constant. So that's okay too. They cannot both be 0, because if a was 0 and b was 0, then I'd lose the x and y, and it would no longer have any form of variable. So another thing to mention about linear equations would be the x and y can't have any exponents or anything like that. It needs to be what we call first degree. Okay, so just plain x and plain y, no x squared, no square roots, no anything else other than just x to the first power, or just x. Same thing with y. So now that we know kind of what a linear equation looks like, linear equations form lines, as mentioned in the name. So the line could be going up, it could be increasing, it could be going down, it could be horizontal, or it could be vertical. If we want to know if an ordered pair is a solution to a linear equation, that means we're asking, is this ordered pair on the line? If it is on the line, it's a solution. If it's somewhere over here, it's not on the line, and it's not a solution. Well, how do we algebraically determine whether or not it's a solution? Ordered pairs always go x, y. So we just plug in the values for each into our linear equation to see if it forms a true statement or not. So in this case, x is -5, and y I'm going to replace with 6, and see if this ends up being true. So -5 plus 6 is +1. 1 does not equal 11, so no, not a solution. And visually what that means is if it's not a solution, it's not on the line. It's somewhere off in the abyss. Now let's look at the ones on the right. So ordered pairs always go x, y. So my x value is -1/4, my y value is 13. I'm going to replace them into this linear equation, 4x plus y equals 12. Replacing x with -1/4 and y with 13. I follow order of operations to simplify. 4 times -1/4. So positive times a negative is going to end up negative. And I can turn this 4 into a fraction by putting it over 1. The 4's divide out, and now I have +1 times -1, which will end up -1, plus 13 equals 12. Well, 13 take away 1 will be 12. That's true. So yes, it is a solution. Let's try the next example, B. Again, ordered pairs go x, y. Same linear equation, this is the same example, just a different ordered pair. I'm going to replace x with -1 now, y with 8. So now I have 4 times a -1, which will give me -4. I'll write this over here, plus 8. A +8 plus a -4 ends up +4, which does not equal 12. No, this is not a solution. Lastly, 1/2 1 ordered pair is xy. Replacing x with 1/2. Replacing y with 1. I have 4 times 1/2. That is 2 plus 1. 2 plus 1 is 3. That will not be 12. No, not a solution. To recap, if you end up with a true statement, so 12 equaling 12, it will be a solution. If you end up with a false statement, it will not be a solution.